This video describes another method of integrating 1 over x to the fourth plus 1. So this is what you get out of it, and so let's erase all of that. Let's just go through all the steps together, and at the end of the video I challenge BlackPenRedPen to check the differentiation. So let's turn on a light and begin. So we have integral 1 on x to the fourth plus 1 dx, right? Okay, so how would we start off by doing this? Well, what I'm going to do is instead of integrating that, I'm going to replace that 1 with the 2. Now, I can replace that 2 by 1 minus x squared, or on x to the fourth plus 1 dx, and then plus 1 plus x squared on x to the fourth plus 1 dx, because the x squared, positive x squared, and the negative x squared cancel each other out. Now what I'm going to do is divide by x squared on the top and bottom. 1 on x squared minus 1 over x squared plus 1 over x squared, and plus integral 1 on x squared plus 1 on the same thing. Right there's going to be dx as well. So now, if you have the x squared plus 1 on x squared, you can rewrite this as x plus 1 on x squared minus 2, or as x minus 1 on x plus 2 squared. Okay. You can barely see any of this, so I'm just gonna bring... Okay. So now, after that, what I'm going to do is for this first integral, right? For the first integral, I'm going to make the substitution u equals x plus 1 over x, so that du is going to be 1 minus 1 on x squared. 1 minus 1 on x squared. Okay? And then for the second one, I'm going to make the substitution t equals x minus 1 over x, so that dt is going to be 1 plus 1 on x squared. Right? So then, what do I get out of it? So by this, I can write the denominator as u squared minus 2 for that one. So that's going to be u squared minus 2 on the bottom. Right? And on the top, I'm going to have negative du, because you see the signs flip, negative du. And then we're going to have plus the integral of, well, dt's on the top just straight. And then on the bottom, we're going to have t squared plus 2. So what do I get out of this? Well, I get negative. I'm going to write this in terms of the logarithm, just so it matches pretty closely with BlackPenRedPen's answer. So it's going to be 1 over 2 just rad 2, sorry. 2 rad 2. Negative 1 over 2 rad 2 times the natural log of u minus rad 2 on u plus rad 2. Okay? And plus, and then we're going to have 1 on rad 2 arctangent. We're going to have u on rad 2 plus c. Okay. Now what are we going to get? We're going to get negative 1 on 2 rad 2 natural log of u is x plus 1 over x plus 1 over x minus square root 2 on x plus 1 over x plus square root 2, right? And plus 1 over rad 2 times arctangent of, then u is going to be x plus 1 over x, x minus 1 over x, because this should be a t, sorry. X minus 1 over x on square root 2 plus c. I'm going to simplify this, bring that negative in, so you do the reciprocal. So then I'm going to have 1 over 2 rad 2 natural log of, I'm going to multiply the top and the bottom by x, so I get x squared plus square root 2x plus 1 divided by x squared minus square root 2x plus 1 plus 1 on square root 2 arctangent of, multiply the top and the bottom by x, so I get x squared minus 1 on square root 2 x plus c. Now you can simplify this further, but this is the furthest I'm going to go. And then this is 2x to the fourth plus 1, so I need to multiply this by 1/2, which is pretty easy to do. 2 square root 2. Okay, so then this is the final answer for the integral. Okay, so BlackPenRedPen, you should differentiate this, and if you don't do it in like 5 days, I'll be severely disappointed in you.